Okay, good evening, everyone. Thank you for joining me today. I'm Jamaluddin Jasmis, representing my fellow friends from University Technology Mara, Chawang Melaka, and today I will present our research on managing user requirements engineering with automated speech recognition and natural language processing tools. This project was developed with the goal of improving how user requirements are captured and classified, moving beyond traditional manual approaches. Software engineering relies heavily on capturing clear and accurate requirements. Requirements engineering, or RE, is one of the most knowledge intensive tasks in the development lifecycle. While development tools have advanced rapidly, documentation and user requirements gathering remain largely manual. Poorly requirements gathering remains Poorly captured requirements often lead to project failures. Traditionally, this is done through interviews or workshops, but these methods are prone to ambiguity and loss of detail, especially when requirements are gathered through spoken communication. This project addresses the critical challenges in eliciting and classifying software requirements using a modern automated tools integrating speech recognition tools and natural language processing. Firstly, most user requirements are communicated in natural language, about 90%. In fact, traditional requirements gathering methods such as interviews and focus group often result in communication issues, but interpreting and classifying these into functional and non-functional requirements is challenging. Add to that communication gap between technical teams and non-technical stakeholders, and it's become clear how errors propagate. Technical jargon and subjective interpretations can lead to misunderstandings and misclassified requirements. These, in turn, affect software quality and user satisfaction. Lastly, there is a critical need for accurate classification of requirement, specifically distinguishing between functional requirements and non-functional requirements. Misclassifying this can lead to flawed system design or unmet performance expectations. These challenges form the core motivation for our work, and we aim to address them with a more structured and reliable approach. Our solution is a web-based tool. Users speak into a microphone and the system use speech recognition to transcribe their input into text. That Then the text is passed through an NLP engine to classify it into functional or non-functional requirement. We use support vector machine algorithms for classification and trained on both the promised dataset and accurate dataset from Kaggle. The outcome is a structured list of requirements with high classification accuracy. To address this challenge we identified earlier, we have explored and integrated several key tools and technologies. First, for voice to text conversion, we utilize tools like Python speech recognition and the web speech API. This allows us to convert spoken input such as from interviews or discussions into text, making it easier to analyze requirements in their raw form. Next, we use Monkey Learn API as our text analyzer. Okay, this tool helps us process natural language data, extracting keywords, sentiments, and topic classifications, which are essential for identifying potential requirements. Finally, we apply a machine learning classification model based on support vector machine. This classifier helps us automatically distinguish between functional requirement and non-functional requirements, improving accuracy and reducing manual effort. Together, these tools form a robust pipeline to enhance the requirement elicitation and classification process. Here you can see the system use case diagram. It includes 6 key actions. First, user can enable speech recognition, speech their requirement, and view them transcribed in the interface. Then, they can classify the tag using our embedded classifier. The system handles the classification automatically and displays the output in the tabular format of functional requirements and non-functional requirements. Okay, this is the tool's operational flow. The user clicks Start Record and begins speaking. Next, the tool transcribes the speech into text. Next, the user confirms the transcription. Okay. Then, if accepted, the system classifies the requirement into functional requirements or non-functional requirements. Okay. Lastly, results are displayed and the user can either restart or end the session. This simple flow allows seamless interaction even for non-technical users. Our classifiers were trained using the Promise repository, a well-known data set in software engineering. Okay, a Kaggle data set that include real-world functional requirements and non-functional requirements. We use label data to train the support vector machine classifier through monkey-learns API. Features like keyword frequency, sentence structure, and semantic indicators were extracted using TF-IDF and post tagging. Okay, here's how the classification works. Speech input is transcribed to text. The SVM model processes it and predicts whether it is a functional or non-functional requirements. Tag confidence level are used to verify prediction reliability. Misclassifications can be manually corrected, which also helps the model learn over time. Our classification achieve high precision and recall. Functional requirements 93% precision, 91% recall. Non-functional requirements 94% precision, 96% recall. These figures shows that the model correctly identifies and categorizes the most inputs and with minimal errors. Functional testing was done using black box techniques to verify button operations and UI behavior. Accuracy testing was done using a confusion matrix. Functional requirements accuracy 70%, non-functional requirements accuracy 90%, overall accuracy approximately 80%. Despite being a binary classification task, these results are strong indicators of a robust and generalizable model. Okay, as a result summary, first, our model achieved high precision and recall scores. This indicates that the classifier is both accurate in its precision and consistent in identifying the correct type of requirements. Secondly, the computation metrics used in our evaluation demonstrate that the classification process is effective and reliable, with minimal misclassification between functional and non-functional requirements. Lastly, The tool has proven to enhance the requirement elicitation process. It provides better support for managing and organizing requirements, which is crucial for improving project clarity and reducing rework. These results validate the effectiveness of the proposed approach in addressing the earlier identified challenges. Okay, to conclude, we have demonstrated that the speech to text combined with NLP can significantly improve requirements elicitation and classification. Our tools is easy to use, highly accurate, and address a common bottleneck in software engineering. Future improvement may include software automated stakeholder recognition, smart requirement extraction, and more adaptable and scalable NLP model. Okay, so lastly, we would like to thank University Technology Mara and all our collaborators for their support in this research. If you need to collaborate or ask questions, feel free to contact me at the at the emails address stated there. Okay, thank you very much. Assalamualaikum.